I was telling you that I will go through some of the common exam questions. So here we go. Now, 90% of the time, right, the exam paper will definitely ask you which material is a better conductor of heat, which one is a poorer conductor of heat. Okay, it is a question that definitely come up for exam, almost definitely, because after they ask you which material is a good or poor conductor, there will be another question that's based on that, or they'll ask you, or for example, they ask you which material will you use to make a certain object. Okay, now let's look at two common ways they'll ask whether or not is a material a good or poor conductor. Okay, so let's look at the graph on the left side. So if you look at it, you realize that for x, right, okay, actually for x, y, and z, but for x, in 30 minutes, the temperature decreased the least. That means it dropped the least, the temperature. Whereas for z, right, the temperature decreased the most. So if you have been listening to the previous video about heat and temperature, you realize that an object that temperature can rise or fall very quickly is a better conductor of heat. Therefore, you can conclude that Z is a best conductor of heat, whereas X is the poorest conductor of heat. Okay, then let's look at the question on the right side. So you have three materials. They tell you that D took the longest time to melt, whereas E took the shortest time to melt. Okay, so this one is the shortest time. Remember that. So what does it mean when the wax takes the shortest time to melt? So basically, wax, when it gains heat, right, it will melt and then become liquid. So what does it mean that when a wax melt the fastest? If it melts the fastest, that means the material can transfer heat the fastest, or you can say conduct heat. Okay, if it can conduct heat the fastest, that means it's the best conductor of heat. Okay, and likewise for D, right, it took the longest time to melt. That means the material F conducts heat very slowly, so it is the poorest conductor of heat. Okay, so that's how you infer whether or not a material is a better or poorer conductor. Then the other thing you need to take note is when you are comparing two material, then you use better or poorer. When you are comparing three or more, you use best or poorest. Okay, by right, during exam they will not fault you for your English. So why is it that you cannot write good and bad? The reason is very simple. For example, if you look at the graph on the left side, okay, let's say X, Y, Z, maybe all of them are poor conductor. All of them is poor conductor. It's just that X is the poorest conductor of heat. Okay, so you cannot say that Z is a good conductor, because Z is also a poor conductor. Just that Z is the best conductor among all these three poor conductor. Okay, so that's why you should use comparative words. Okay, so for example, you can say that Z is the best conductor of heat. Okay, you don't say Z is a good conductor like I tell you, because maybe Z is a poor conductor. It's just that among the three, it is the best. Or you can say X is the poorest conductor. So this is another common question that will come out during exam. So let's say all three rods are made from the same material, and the only differences between them is their sizes, okay, their volume. Which one will reach 100 degrees Celsius first? To understand this question, you have to think about water. Okay, if you were to boil water, if you boil very little water, the water will boil faster. Whereas if you boil a lot of water, it will take longer time for the water to boil. So it's the same thing. So you expect that because rod B has the most volume, right? So it will take the longest time. Reason very simple, because rod B will require more heat to reach 100 degrees Celsius because it has a more volume. Okay. Now, this is another question. It's a trick question actually. This one, they tell you that you put this both the cup. One is the wooden cup, one is a metal cup, okay, aluminum cup. You put them in the fridge for 8 hours. Okay, what's the temperature? Okay, if let's say they tell you the aluminum is after 8 hours it is 5 degrees Celsius. Okay, what will the temperature of the wood be? A lot of students will think that, after 8 hours, aluminum will be 5 degrees Celsius. So the wood must be warmer, because the wood is a poorer conductor. So probably they will say maybe 8 degrees Celsius. 10 degrees Celsius because it's supposed to be warmer than the metal. That's wrong. Okay, after 8 hours, they will both have reached the room temperature of the fridge, meaning the temperature of the fridge inside, which is 5 degrees Celsius. So after 8 hours, I leave in the fridge for so long, both will feel like, sorry, both will be 5 degrees Celsius ready. Okay, but I mean, if you think about it logically, if you put something in the fridge for so long, if you have at home, if you ever tried it, you can hold the I don't know, metal cup and the wooden cup, you realize, why is it that the metal cup feels colder? But are they really both 5 degrees Celsius? The answer is yes, they are both 5 degrees Celsius. And the reason why the metal cup will feel colder is because, like I told you during the previous video, okay, aluminium or metal is a better conductor of heat. Since the metal is a better conductor of heat, your hand will lose heat faster to the cold metal cup. So we will feel cold not because it is cold, I told you before. We feel cold mainly because we lose heat. So if your body is losing heat faster, you feel colder. So that's why the aluminum cup and wooden cup, although they are the same temperature, but because your hand is losing faster to the metal cup, that's why the aluminum cup will feel colder, but it is actually the same temperature. This question appear in exam, then you are lucky lah, because they ask you very straightforward. And what they are usually asking is they are asking you, out of these four material, right, or these four object, which one has the most heat? Okay, so as I was telling you, obviously higher temperature will have more heat, so we just focus on these two. And then for R and S, right, because the volume is more, okay, therefore it has more heat. Okay, why? Because like I say before in the previous video, if you boil 2 water, the one with more water will take a longer time to boil because it needs more heat. So when the temperature is the same but your volume is higher, that means it has more heat inside. Okay, on the next slide we'll look at a tricky way of asking this question. Okay, it's asking you the same logic, but they asked it in a more fanciful way. This is actually asking you which container the water inside has the most heat, but they're asking in a fanciful way. Instead of straightforward asking you which water container has the most heat, they ask you which one will cook the egg faster. Okay, obviously if the water has more heat, the egg will cook faster, correct not? So let's look at which water will have the most heat. So I told you before, when the volume is higher, you have more volume of water. Okay, more volume meaning more heat, but also you need to look at the temperature, okay. So you realize that both B and D, both of them is 85 degrees Celsius, but because it has the volume is the highest, right? So this one has the most heat, so this is number 1. Okay, then the 100 milliliter one, it has 85 degrees Celsius but lesser water than B, so that's why it has a second most amount of heat. Then the remaining two, right, both is 50 degrees Celsius, but because setup A has more water, right, as compared to setup C, so this one has the third most amount of heat, followed by the last one. So logically, like I tell you, when you have more heat, the egg will cook faster, so like the numbers suggest, it is B, D, A, C. Okay, that's the next one. Okay, so this has to do with when an object gains heat and lose heat, and then it will expand or contract, right? So we know that heat expand, cold contract. You must remember this. So I repeat again, heat expand. This is a concept you must remember. Cold contract. Okay. I don't know if you all have ever experienced this at home, but sometimes if you have a container that wants to twist open, that's left in the fridge for too long, the cover is stuck. Sometimes your parents or the adults at home will put the cover in the hot water, okay, because the cover will expand, so when it's expand it becomes loose, then it's easier to open. So for this one it's the same logic, okay. The one that you want to expand must be in hot water, the one that you want to contract must be in cold water. Okay, So this is what Keith has done. Okay, he put it in ice, right? So this one you lose it lor. So when you lose it, you contract and become smaller. When you contract and become smaller, it's easier to remove. Okay, this one is in hot water, right? So you gain heat, and then after that you will expand. Okay, so you can phrase your answer something like this. Okay, the inner glass will lose heat to the ice and contract, while the outer glass will gain heat from the hot water and expand. Okay, and they'll become loose. What this question is asking is, do you have the two beakers of water, beaker A, beaker B as shown? Okay, they are both 90 degrees Celsius. The only difference is the amount of water inside. Okay, obviously just now we already went through when you have the volume is higher and the temperature is the same, that means beaker A has more heat. Okay, so it has, that also means that it has more heat to lose lah. Okay, because it has more heat lah. So therefore, since it has more heat to lose, the temperature will drop slower as compared to beaker B lah, which have less heat to lose. So your beaker A's line, right, is supposed to be, it will take a longer to drop lah. Okay, so let's look at the four options. Like I say, A must take a longer time to reach the same temperature as B, right? So this is, as of now, this is correct. This is wrong already. This is telling you A's temperature drop very fast, which is wrong. Okay, this is also wrong. So only these two is correct. Okay, now the other thing you need to take note is this. They left it in a table. Table, that means room temperature. Okay, the room temperature in Singapore is about between 25 degrees Celsius to sometimes 30. Okay, I don't think Singapore will drop to 0. So because you left it in the table, right, so you do not expect the water to reach 0 degrees Celsius. This is 0 as you can see. So this is wrong. This will only be correct if he put the beaker in the fridge. If you put it in the fridge or the freezer, then it will drop to the room temperature of the freezer, the temperature in the freezer, which is 0 lah. But in this case, they left it in the room, right? So it will drop to the room temperature. So your answer is number 1. Okay, this is another question. So they'll tell you, hey, there's this guy, he put a spoon into hot water. Does putting a metal spoon into hot water makes the hot water lose heat faster? Okay, the answer is yes, because I told you already, metal is a good conductor of heat and air is a poor conductor of heat. Okay, so metal will conduct heat away from the hot water faster than the surrounding air. Okay, so because of that, the metal spoon can conduct heat away faster, so the hot water will lose heat faster, and that means the hot water temperature will drop faster. Other than whether or not an object is a good or poor conductor affecting how fast they gain heat, the other thing that will affect how fast heat gain is the surface contact. So if you look at container A and B, let's say everything is the same, the amount of water is the same. Okay, the only difference you will notice here is the surface contact, right? So container has more surface contact as container B, right? That means this one will gain heat faster. Okay, whereas this one has less contact, so it will gain heat slower. Okay, so you can just say that container A will boil first because the water in container A has more surface contact with the hot plate. Okay, let's wrap up this session with another common question. This is a full question. This is like the one that I told you previously. They will ask you which material is a better conductor of heat, poorer conductor of heat. Then they will ask you which material will you use to make a certain object. So basically this 4 setup is the same, it's exactly the same. They all has water inside. All the water starting temperature is 4 degrees Celsius. The only difference between these 4 setup is that they are all surrounded by different types of material. Some of them is a better conductor of heat, whereas some is a poorer conductor of heat. If you look at them, the results at the bottom, you realize that this one temperature only +2, whereas setup Q, the temperature increased by 16. +6 +11. Okay, so just focus on the extreme one, which is P and Q. So for P, right, you can conclude the temperature increased the least. The temperature increase the least, right? Okay, when the water temperature increase the least, that means it gains heat slowly. If it gains heat slowly, that means the material that is surrounding it transfer heat to the material slowest. So this material must be the porous conductor of heat. Okay, porous conductor. Then this one, the heat increase the most, right? That means the water inside gain heat the fastest. If the water inside gain heat the fastest, that means the material is able to transfer heat to the water faster. So that means this material is the best conductor of heat. Okay, so if let's say the question asks you which material is the best conductor of heat, right? As I mentioned already, Q is the best conductor of heat lah. Okay, the reason being, the water in material Q, it can heat the fastest. Okay, then so now you have another question. They say this boy, he wants to hold a bowl of hot soup without scalding it himself. So which material must you use? So if you want to protect yourself, right? Okay, to hold the bowl of hot soup without scalding yourself, you must use a poor conductor. Okay, because if you use a good conductor, it will transfer heat to your hand quickly, and then your hand will be scald. Okay, so as I was telling you, material P is the porous conductor, right? So your answer should be material P. And reason being, material P is the porous conductor of heat. Okay, then your explanation will be because the material will gain heat slowest from the hot soup. So the material will become hot slower, so your hand won't be scald. Okay, that's all for today. If you can, please share the video with your friends